In this video, we are going to learn about complement of sets. So first, let's see the definition of the complement. So let's suppose we have a set A and we are to find out the complement of A, which is denoted by prime. So A complement is basically a set which consists of all those elements of the universal set which are not the elements of A. That means complement of A is such a set which consists of all those elements which are not in A. Let's try to reinforce this concept by doing some more problems. So let's start off. So let's do some practice. Here we have a universal set and set A. Universal set is a set which consists of all those elements which are in consideration. So this is basically a grand set, or you can say it is a kind of a superset which consists of all the elements which are in consideration. Complement of a set has to do with the universal set. So universal set and set A, and we are to find out a complement all those elements of a universal set which are not in A. Okay, so except A, all the elements which are in universal set. So A complement is written as U minus A. So what we do is we have it is like a difference operation, but when it comes to complement, so it is always subtracted from the universal set. So 1 2 3 4 5, and then we have A, which is 1 3 5. So in difference, what we do, we take away the common elements, and the remaining elements which are left in the first set, we write them. So here we have 1 which is common, so let's cut it down. We have 3 which is common, and then we have 5 which is common. So we are left with 2 and 4 in this case. So this is the A complement. That means these are all those elements which are not in A, but they are in universal set. So I hope you get the idea. Now let's draw the Venn diagram. Venn diagram of a universal set is always a rectangle. So this is the U set, and inside U we have A, which is here, and in A, okay, if you see here, we have 1 3 and 5 common. So 1 3 5 common, and we have 2 and 4 which is left in universal set. So this is A complement. So here we are going to shade this area because this denotes A complement. These are all those elements which are not in A. Let's do some more practice. Okay, so this is another problem, and here we have to work out for B complement. B complement means all those elements which are not in B. So you can either do it directly because it is quite obvious. We have 1 common, we have 3 common, we have 5 common, and we have 7 common. So you can write all those elements which are left. So we are left with 2, we are left with 4, we are left with 6, and we are left with 8. So 2 4 6 8. So I have done this directly. So this is basically, let's draw the Venn diagram in this case. So universal set goes in this rectangle. So this is our universal set. Okay, inside universal set we have set B, which has all the common elements. 1 is common, and 3 is common, 5 is common, and 7 is common. So these are all the common elements, and since we are working for B complement, so it comprises of all those elements which are not in B. So we are basically left with 2 4 6 8 in the universal set. So here we go. So this is our B complement. So we have worked out graphically as well as in the tabular form. So I hope you get this. Now we are going to see three different cases regarding the complement, which are very important to be noted, right? So let's first, the first case is regarding the complement of the null set. Okay, you know very well the null set is such kind of a set which does not contain any element or which is empty. So these are the two ways we notate the null set. Now complement of the null set. So let's see that how do we write in our mathematical language. So we have the null set and the complement of it. Now we know that complement has to do something with the universal set. Okay, so universal set minus the complement. So the complement of null set means u minus null set, right? Pause the video and try to guess that what would be the answer of it. If we subtract a null set from the universal set, then what we're going to get? Let's see with an example. Let's say we have u set equals to 1, 2, 3, 4, 5. Let's suppose. So we are to find out the null complement or the complement of the null set, which says u minus null set. U is 1, 2, 3, 4, 5 minus the empty set or the null set. So you can see here there is nothing common in these two sets that we can omit or we can cut. So the whole set is your answer. That is 1, 2, 3, 4, 5. So now you get the idea that if you have null complement or the complement of the null set, that is u minus null set, the answer is going to be always universal set. So the second case we have is the complement of the universal set. So you know very well that universal set is denoted by U, or it is a set which contains all the possible elements of concern, right? So complement of U, so U and this prime, that is U complement. You know very well that complement has to do with the universal set, so U minus U. So what's going to be the answer? Pause the video and try to guess. Okay, now, so I hope that you got the answer, but now let's see with an example so that those of you who didn't get it, they may understand. Okay, so let's say that we have a U set which is A, B, C, D. Right, it's just to explain you. So now we have to find out the U complement, so which is U minus U, and the set U in both the cases is same, of course, A, B, C, D minus A, B, C, D. Now we are going to see for the common elements. So we have A common, B, C, and D. So we are left with no element here. So we have got the null set. So whenever we have U complement, that is U minus U, we always end up getting the null set. Okay, so the case number 3 is the complement of a set. Now what does it mean? Let's say the set is A, and now let's jot it down. So the first complement, the complement of the set, right? Now this complement, the complement of this set, so it's like double complement, right? So now let's simplify it because it has become really horrific. So first let's see this inner one, which is A complement. Now you know what is A complement. A complement is nothing but U minus A. Now this complement is here. what this complement means. It means u minus this whole thing, that is u minus a. Okay, so now if you know a little bit of algebra, then it is u. Let's open up the brackets. Since we have minus here, so all the signs inside would be altered. Here we have plus, so it would be minus u, and here we have minus, so it would be plus a, right? Now you know it, plus and minus cancel, so we are left with a. So what's the answer? The complement of a set is the original set. That means if you take the double complement of something, you'll get the same set. You'll get the original set. For example, you have b double complement, so it means it's equals to b. If you have y double complement, so you'll end up getting y as your original set. So now I hope that compliments are easy for you. So have a happy learning. Stay tuned to my channel. Don't forget to like, share, and subscribe to my channel.